Hello and welcome to another one of D's ADD videos. Today we're going to be discussing volume of solid revolution. The concept here is we're going to be taking some function and basically rotating it around the x-axis. So for instance, if I have the function square root of x and I stop it at the line x equals 9, and I did some rotating there, what would happen? Well, this is what would happen. We would get a bowl-like shape, paraboloid if you will. Okay. And if we were to take a cross-sectional area of this, what we would end up with is a disk, which would have an area of pi r squared. Okay. Now, if we have two regions, for instance, let's say we had the line, oops, let me do my axis in the same color. Not that it matters, but just be consistent. So let's add the line y equals 1 to that equation. To that orange. Now what happens when I rotate it? Well, the outer surface is still that, right? But now we're going to have an inner surface as well that's no longer the x-axis. Alright, so when we rotate it, we'll still have that bowl, but it won't be solid anymore. We'll have that big chunk missing out of it inside there. Okay, hopefully you can visualize that. So that's more of a washer. Okay, and we're still going to have a cross-sectional area of a circle, except for it's just going to have a big hole in the middle of it. Okay, that's why it kind of looks like a washer there. The region we're rotating all depends on whether it's a disk or a washer. So this one would be area of the outer minus the inner. Okay, and the outer was root x, right? And the inner was y equals x. So in this case we would have pi outer being so it's pi outer radius squared minus pi inner radius squared. Alright, so this is just to set up the area part of the formula, but how do you actually get the volume? Well, the volume is going to be equal to the integral of the area, and we're either going to look at it in terms of x dx if we rotate about the x-axis, or some horizontal line. And I'll show you an example of that later. And then the formula changes, though, from my a to b, to v equals a of y dy. And I'll go from a to b. Okay. So then at that point, we're rotating about the y-axis, or some vertical line. Okay, we could have just as easily rotated this square root of x up there about the y-axis, and it would have looked something like this. Actually, let's do my function in a different color. Let's take the red. So there's the square root of x, and it stops at 9, right? So if I were to rotate that, what I'd end up with is the mirror image on this side. Kind of forming, oops, my pen just did something weird there. And we would get an upside down symbol looking thing if we were to rotate like that. Alright, so that would be a dy type problem right there. The best way to do these is just to practice. Again, if it's about the main axis, whether x or y, it's going to be the disk method, and we're just going to have one formula because the inner radius would be 0, right? The general theme here is outer area minus the inner area, and we integrate that to get the volume. D whatever, depending on what type of revolution we do. Okay, so make sure you understand this concept because some of them do get a little tricky. Check out the example videos to clarify any doubts that you might have still lingering. And most importantly, practice. Thank you and have a nice day.